Hi everyone, this is Dr. Idhanashekaran, Associate Professor, Department of Chemistry, Nanda College of Technology, Erode. Today we are going to discuss about the softening of hot water. So what is the softening of hot water? The softening of hot water can be done by the following two methods. There is a Joule process, another one is ion exchange process. Let us see the ion exchange process or demyelination process. The ion exchange process is carried out with ion exchange resins. First of all, what is ion exchange resins? Ion exchange resins are insoluble cross-linked long-chain organic polymers with a microporous structure and the functional groups. The functional groups attached to the chain is responsible for the ion exchange properties. See the image 1. This is a ion exchange resin just like glass beads. If we go for the individual glass beads, it consists of a polymeric chain. These are cross-linked with each other. Okay. Move to the next one. What are the types of ion exchange resin? There are two different types of ion exchange resins: cation exchange resins and anion exchange resins. The cation exchange resin is denoted as RH plus. It consists of strongly acidic sulfonyl group or weakly acidic carboxyl groups. These cation exchange resins can capable of exchanging their H plus ions with other cations present in the hot water. Similarly, the anion exchange resins is denoted as ROH minus. It either consists of a substitute hydroxylamine or West substitute hydroxylamine. The small substitute hydroxylamine is strongly basic, whereas less substitute hydroxylamine is weakly basic. These anion exchange resins are capable of exchanging their anions with other anion present in the hot water. Okay. Move to the structure of cation and anion exchange resins. Come to the first one. This is a cation exchange resins. The structure of this cation exchange resin consists of a polymeric molecules with the functional groups sulfonic acid functional groups. All the each four polymeric chains are held together or cross-linked with one another. Okay. Similarly, the anion exchange resins consists of a polymeric molecules with the functional groups of hydroxylamine. All the polymeric molecules are cross-linked. These are the structure of cation exchange resins and anion exchange resins. Okay. Now move to the ion exchange purifier or softener. This diagram represents the ion exchange purifier or softener. This consists of this is a cation exchanger column. This is anion exchanger column. The cation exchanger column is packed with cation exchange resin. This is packed with anion exchange resins. Now, so it's associated with the acidic solution for the regeneration of cation exchange resin, basic solution or alkaline solution for the regeneration of anion exchange resins. Let us start the purification process. Now, the hard water, it consists of dissolved salts of calcium, magnesium, sodium, and potassium ions. When it feeds into the cation exchanger column, the cation exchanger resins can exchange their H plus ions with the cation present in the hot water. As a result, all the cation present in the hot water is exchanged by the cation exchange resin. As a result, the water is free from all the cations and cations. Now the water is free from cations. Let us move to the anion exchanger resin column. Now the anion exchange resins will exchange the hydroxyl ion with the anion present in the hot water. At the end, all the anions are exchanged by the anion exchange resin. The resultant water is free from anions. As a result, the water is free from all cations and anions. This water is known as a soft water. So, what is the hard water and soft water? If the water consists of different types of cations and anions, this is known as a hard water. If the water is free from all cations and anions, is known as a soft water. The same process will repeat and again endlessly means no. After some time, the reactivity of the cation exchange resins and anion exchange resins become inactive or passive. The purification process won't take place. At this state, you have to refresh or regenerate the resins. The cation exchange resins can be regenerated by adding the acidic solution. The anion exchange resins can be regenerated by adding the alkaline solution. Okay. Now move to the reactions taking place in the purification process. Come to the reaction taking place at cation exchange resins. In at cation exchange resin column, the cation exchange resins can exchange H plus ions with the cations present in the hot water. Similarly, the calcium ions are replaced with H plus ions, and similarly the magnesium ions is replaced with H plus ions. As a result, the water is free from calcium and magnesium ions because the calcium and magnesium ions are retained with cation exchanger itself. Now the water consists of only H plus ions. Now, similarly, when the water is fed into the anion exchange resistance column, the anion exchange resistance can exchange the hydroxyl with the hot water of the anions. Then, as a result, all the anions are retained with the anion exchange resistance. Now, the resultant water consists of only hydroxyl. As a result, finally, we are getting the water molecules ion. It is free from all the cations and anions. Again, we go for the regeneration of ion exchange resins. The cation exchange resins can be regenerated by adding dilute HCl or sulfuric acid. When you are adding the dilute HCl sulfuric acid, it will replace the calcium magnesium ions present in the ion exchanger. Then again, the cation exchange resins is refreshed or regenerated. Now, the calcium magnesium are removed as a washes. Similarly, the anion oxidases can be regenerated by adding the dilute sodium hydroxide. When you are adding the dilute sodium hydroxide, the anions present in the anion oxidases can be exchanged with hydroxide ion and the anion oxidation is regenerated. Then the anions are removed as a washings. Okay. By this way, we can regenerate the ion exchange resins. Okay. Now move to the what are the advantages and disadvantages of the process. The advantages is highly acidic as well as alkaline waters can be softened or treated by this method, and also the resultant water consists of only hardness 1 to 2 ppm, whereas the hard water consists of a hardness around 1000 to 1500 ppm. Okay, this water is used for the high pressure furnace. So the disadvantages are the initial setup cost is too high, and also the cost of the chemical, that is resins are too high. One more disadvantage is the double water cannot be treated by this method because the resulting water hardness will be more than 1000 ppm.